by a esteemed panel here. Talk a little bit about the future of autonomy. I'll let everybody introduce themselves real quick, just a quick 30-seconder.
Yep.
And then I'll sort of dig into the conversation.
Chee Gansberger, I'm a program manager for a program called Rapid at AppWorks, the robotics and autonomy platform for interoperable devices. I'm also the software manager for AppWorks Prime.
Hey y'all, Salsa Lopez, Rupert Pilots assigned to AppWorks, working as the robotics and machine learning lead.
Everybody, John Goodson, CEO at Darkive, former Navy combat tech, supporting West Coast SEAL teams. Yeah, doing drone stuff now.
Fine, I'm a JTAC.
Yeah.
It's like, oh,
I was surprised you didn't do that.
Yeah.
I was surprised you didn't volunteer that immediately. Yeah.
All right, so as we start, I think recent events, especially the last couple of years, have, I think, shown the impact that, drones, autonomous systems, commercial software can have on the battlefield. I think it's come a long way. I remember, I think the first time I was getting Ravens, and some of those we couldn't figure out how to use them, so we just crashed them into people. We're now able to use them to do a whole bunch more. What do you think the implications, and Chee, I'll get this to you first. As you look at sort of Ukraine, some of the stuff that's happening there, also look at some sort of the proving ground aspect of all the commercial tech coming in. What do you think sort of the implications are broader for U.S. national security and defense, how we're looking at some of our larger programs, and then where do you think we have issues that maybe we're not seeing yet?
Well, I'd say the biggest impact, how you worded that, is not even so much just, and I know this panel is about autonomy, but I'd reach on to the commercial side, because the moment you said the Raven, I just think of, as a JTAC, all the different systems I've been trained on, and it's been a ton. The ones that were commercial were really easy to get my hands on and figure out. And the ones like the Raven that came from a prime built by a bunch of requirements documents that went through a program office, we would just crash them into people because that was the only effective use. Nobody was going to ever actually use it. What we're seeing in Ukraine is taking that commercial off the shelf stuff, and because it iterates so rapidly, the dudes on the ground are able to actually develop TTP, and then of course the enemy develops TTP, and you've ended up with this really, really concentric OODA loop of not just acquisitions, but tactics that are building on top of each other only because commercial innovation is happening so fast. We're now seeing that innovation being so fast, leaning into autonomy for software can actually now overpower the speed of the human mind that's involved in these jamming or remote controls where there is no remote control. I let the robot go do it. But we also have to step back and say, hey, we're gonna take the gloves off and let commercial innovation, especially the U.S. commercial innovation and artificial intelligence, kind of take the lead on that. Otherwise, we're just gonna get buried by other peers.
Salsa, as you look at concepts of autonomy and sort of, I think there are a lot of words thrown around. I think DoD is great at acronyms and program names and buzzwords, and they usually sort of, maybe they skimp a little bit on the technical understanding. Where are you seeing sort of pockets of actual adopters that are looking and trying to build in at that technical level and really understand how we're looking at interoperability and autonomy? And conversely, if you want to name and shame, where are you seeing sort of resistance or maybe fluff without some of the meat?
For sure. So I'll start with where we see things going downrange, right? It's this push into commercial, the push for this OODA loop, right, that needs to be so fast. In order to do that, I need to adopt the commercial, not the government standard. And so I think in the DoD previously, when we built these large weapon systems, we generally would create standards. And we have standards everywhere. We have MISB standards. We have lots of really great things that actually do allow us to do good information sharing, good data sharing. I think as we lean into what I will call robotics, vice autonomy, and there's a reason for that. When we lean into the robotics sector and we lean into something like UAS, those things have already been developed. And if I'm going to pull something from the commercial side, it's likely also going to come from academia. So I need to lean into both of them and what they're using as their standards. And what they are using is ROS, MAVLink. And these are protocols we already have. So why do we as a government believe that we will create a better standard, one, that will be more widely adopted, likely not, and that we will not incur any tech debt by adopting that new standard that we now require someone else to meet their product to. And so folks like DIU have kind of pioneered what's called the Robotic Autonomous Systems interoperability protocols. And through the kind of joint small UAS working group, we've started to build messaging protocols that are based off of ROS, based off of MadLink on what we expect your robot to tell us. Yep. Not to say that this is what we need to have as a standard for a new protocol, but how are we going to use the existing protocols? And I think that part is really important, because now I've reduced my technical debt when I go and I'm starting to apply a new technology that maybe just came out of academia or out of industry towards the TTP to make those OODA loops much more concentric.
So from a commercial side, someone sort of building platform, coming in, looking at, right, how do we not have all of these tightly integrated sort of vertical silos of capabilities, but we're actually building scalable capability. John, I'd be curious, one, where are you sort of seeing, the government maybe leading in the right way? And then conversely, sort of, what's the implication for you as a commercial provider of maybe some of the disconnected nature of how the government's been approaching autonomy at scale, robotics, so to speak, initially?
Yeah, great question. And I think Salsa already hit on this actually really well, which is from commercial industries perspective, when they're being directed, if they want to work with the government, they're being directed to utilize a particular architecture, a particular protocol, whatever it is. I mean, assuming there's a lot of engineers or people who lead engineering teams in the room, and what's the first question is, okay, cool, where's the documentation? Where are the resources that I can look to better understand how to leverage this platform? And as someone who has been out of uniform and working in defense tech for a number of years now, primarily as an integrator, I can tell you that having gotten that direction from a government sponsor and being told, go find this resource over here, and I say, okay, that's fantastic. I found it, but it says that I need I need permission from a government sponsor to do it. Yeah, call this person. Okay, I call that person. No, don't talk to me, talk to this person. Okay, talk to that person. Okay, cool. You need a SIPR token to be able to get on a classified network in order to access this. That's frustrating for me, and forget me telling my engineering team that. Anybody who runs an engineering team, particularly on the commercial side, what's the answer eventually to a question like that is, screw it, we'll build it ourselves. Like, I'm not going to waste our time doing this. And that is really beneficial to whoever the likely traditional defense prime is who's building that system, and was actually advocating quite heavily for it to be on the other side of a classification barrier so that they could control it and own it and define standards that only their systems are interoperable with. These are the things that, all the way back to the question, are really important considerations for me that Salsa hit really well, which is, you're not going to do better than ROS. It's already broadly adopted. It's industry, it's academia. You're not going to do better than MavLink. You can come up with all sorts of reasons why you need to add custom messages and things like that, but you're not going to do better than it, particularly if you make it a government standard that exists within a silo and is completely inaccessible to anybody else. The success of whether it's the stuff that Salsa and Chee are leading, and they understand this quite well, or success for really high-profile programs like Replicator, all of this is going to really hinge on, if we want to create an ecosystem of partners, software and hardware, that we expect to rally around these types of architectures, they got to be discoverable, especially if you want to pull commercial industry in. That means that when your engineering team is told, hey, you got to integrate with this thing over here, and they say, fine, yet another thing that I have to go and learn about to integrate with. But when they actually go and Google it, they can actually find an API defined, commented out very, very well. They can find examples. They can run online, fully simmed, examples of their software running on a representative platform. Like, these are things that if you do that, that gets the engineers really excited. That gets guys like me who aren't engineers really excited, because you made things really good for my team and it made it happy. That's the type of thing that I think about a lot from the commercial side, and building solutions that notionally will plug into some of these types of programs.
I think, and if I may, I think it's also really important on the government side to provide access to those tools. And so one of the things that we've started adopting on the military side is stitches. And we got your team on there, so www.stitches.mil. Not an AFWERX program, but it's another government program that has.
It's about to be.
Yeah, sorry, it is
Yeah.
about to be. We're adopting it. It is an IL4 ITAR repository where I can have Jupyter notebooks, I can have a GitLab, and I can get it's IL4, it's ITAR, I can get contractors, and I can have there. And I have now a repository of Git that is government owned. That lo and behold has lots of other things like messaging standards. So whenever I ask the team over at Darchive, like, hey, I would like you to integrate with these messages, I can point them to a repository that is documented, that we can put GitHub issues that goes back to the developers, right? And that's so important. And many times, even within the government, when I'm told of something new that someone would like to integrate either with our product or that we want to integrate with someone else's product, the first thing I ask them is, where's the code? And even me as a government person has a hard time getting a hold of the code. Or they don't understand the code because they maybe never asked for it. Maybe it's GPR, and some things are, and there's an argument to be made for non-GPR code. But for the stuff that is GPR, government purpose rights, where is it? How do I go and touch it? And did it actually deliver? And a lot of times the government SMEs, unfortunately, will ask for government purpose rights, but never actually get the code. And when they do get it, they realize that it wasn't quite what they wanted. They got the right product, but not quite the right underlying code that they needed in order to continue expanding. Or we have so much technical debt because we haven't been maintaining it that now we are stuck having to rebuild it. And that's another massive problem.
Yeah. If no one else, I mean, no.
I felt like he was going to talk, so I paused.
No.
Stutter or an idea.
Yeah, I think I just made him happy.
You just made me. You made me real happy. But I mean, the other side of this, I mean, is always it's a little bit, scratching one layer deeper. And when it comes to whether it's government-owned code, government-owned application, industry or otherwise, and this notion of open. When a solution is put out there to be open, to be government-owned, whatever it might be, open to me has always meant, again, coming from the perspective of a systems integrator, open to me means that there's good documentation. There is an interface that is well-defined that I can easily point someone to, and they can very quickly get to work and actually begin interacting with whatever that application may be. And that if I have trouble, there are resources that are available to me to help me leverage it effectively. And those are kind of the three tick boxes for me. Where's the code? Certainly, but how easy is it for someone who has no familiarity with that code to get it up and running, to do build from source, or to troubleshoot things independently without having to get whoever the originator of that application, getting them involved effectively. Like that's open to me. That's kind of the standard.
I'd say where we're going to see a lot of bang for our buck, especially AI, ML, and autonomy, when you start looking into what we're trying to do with robotics is, and I'm keyed on this from you saying GPR, I have a suite of problems, like just a whole lot of things that we're trying to get after. And some of them are very niche to the government. Very, I have just a set search on Amazon. I keep waiting for them to build me drones optimized to go kill an S-400. It's probably never going to happen. So we're going to have to go write that code ourselves. We're going to have to go write a lot of things that go do military specific use cases. Obviously, we want the GPR for all of that because those are our problems. We have to solve our own problems. But there's so many other things that have a dual use case, not just from a hardware perspective, but a software perspective. Leaning on both of those as much as possible. It's easy to make that case for hardware because you're going to buy a lot of hardware in mass. It's harder to tell that story about, like, I would rather just buy licenses from a commercial entity for this dual use software than go build my own in my own software factory. A lot of people think, well, then what, we would own it. Well, then I would own something that was only good the day I built it. And for as long as I'm willing to maintain it at the level I'm willing to maintain, if it's got a large market, there's lots of competition and those vendors are going to innovate. And I would rather just buy those innovations as they get better and better years down the road. So for how we look at this is now I need to rapidly onboard commercial partners, which is why Tyler's on this panel. But that's difficult to do.
My moderation capabilities.
You bring a little something to the fight. But yeah, it's being able to get those commercial partnerships, especially as if we're really going to take advantage of the U.S. having a pivot ahead of our near peer competitors, We have to look at what the US market does well. We don't manufacture well compared to our near peer anymore, but we do innovate especially in IT as an information economy, way better than anybody else. So we need to be leaning on that commercial advantage, and that's going to take a pivot in how the military acquires things.
So using that as sort of the launch into the next section here, and we think about, this last conversation was around sort of building community documentation, right? The right stakeholders around the table and starting to scale that. And you sort of turn the corner into changing that relationship between the communities, right? Which then begs the question, how are we thinking about it from procurement or, congressional sort of regulation? And then what does that look like? Flash forward 2 or 3 years. And, what does this program look like? What are you guys trying to put in place? I'll leave it broad so you can go wherever you want with it.
As soon as you say congressional, I think of, have some friends that worked in Congress 8-9 years ago that, honestly, the congressional tools, the legal tools are already there to be doing innovative things. It is, this term gets thrown around a lot, but the frozen middle, it is reinvigorating the acquisition arms to look at these alternative, AFWorks exists as one of these, DIU exists as one of these, but we're fringe players. We're the lessons that we have for the DoD, especially in commercial partnerships, are not the standard in acquisitions. So I think that needs to change.
Yeah, absolutely. I think ideally as a government, specifically in the robotics space, and we're talking about delivering these capabilities, we are trying to figure out, I think right now with our government partners on what does that tactically look like? What airman is going to be flying these things? What airman is going to be doing the logistics supply chain, charging them, updating the software, pulling the data off? What does the data pipeline look like? These are all massive problems that we don't have answers to yet. And we have some folks across the world in different little bespoke units. They're helping us try and understand how to connect all those things. But in 3 to 5 years, I think what I would love to see is a community of practice and web techs surrounded around this tactical problem of robotics. And how are we best using them? And how are we connecting both of our ML operations as well as our robotics operations? Yes. So for ML, how are you moving data from point A to point B? And how are we effectively connecting data to the right places in the cloud at the speed of relevance? Are we updating and training our computer vision models and then redeploying them? And how are we verifying that those models and the code that's coming in is going to be something that has an acceptable level of risk for that robotics system to go and move forward? So ideally on something like Second Front's platform or other platforms as well, that means lots of commercial companies coming onto the platform and being available for licenses that these airmen can go and pick up, so that this company maybe does really good ML ops. That's likely something the commercial sector is going to do better, more than the government can, right? Because everyone does this. This isn't a government problem, right? But training the specific computer vision model might be an airman function, right? For this specific thing, for that specific mission. But the infrastructure can be theirs. Same thing on the platforms, right? Darkhive has some great platforms that they're building for us. And they're going to have some software that needs to probably go through some CVE testing before we deploy it back. And then someone else may come out with some new software that's open source. Maybe ROS 3, ROS 5 comes out in 3 years, right? As ROS gets updated, how do I push that through the platform and get it there and now start having new heterogeneous and homogeneous capabilities? And how do I enable the airmen to grab whatever robot is on the shelf, 3D print whatever parts they need, optimize their sensor, their shooter, their radio packages, and their all of that onto a platform with the right software, with the right ML ops, put it together and send it downrange. With an ATO and send it downrange, knowing that that has all been okayed. That would be the ideal 3 to 5 years from now. And that happens at the tactical level with support from headquarters, helping build all of the scaffolding, allowing them to move through that process.
Yeah, flatten that kill chain and allowing time to value from a kinetic standpoint or a sense standpoint to get pretty quick. For John, on that, so taking that concept, sort of where Chee and Salsa are talking through it, and then juxtapose that with, I have to come up heterogeneous and homogeneous. We're going to juxtapose now, guys. With disconnected contested spectrum, with real sort of A2AD. I think for my cheap seats, I think we often talk about disconnected and edge capability. We talk about all of this capability, and then I go back the sort of last 20 years of combat, and we fought uncontested spectrum, and we had a really hard freaking time with it. So, someone building those commercial platforms, thinking about, this operational picture and the sort of modular ability for that airman or that soldier, sailor, marine to have a degree of ownership and to be able to deploy. How are you thinking about ways you design, ways you build, the use cases, sort of all that?
Yeah, and it's good because it actually kind of, I think, ties back to how Chee opened us up and in Ukraine today. And when we look at what's working, what's not. What's working today is large volumes of commercially available small drones that are extremely low cost relative to anything the DoD is producing today. The dollar figure that I put on, you hear attritable a lot, you hear disposable. The dollar figure I put on that is $3,000. That's the cost of a Mavic 3 Pro from DJI. And that is the platform that they're largely losing 10,000 a month to, right? And that's a really important number, and it's a really important concept, because when they're losing 10,000 drones a month, they're not shaking their fist in anger. They're very, very happy because the cost per kill relative to the amount of hardware they're taking out with those cheap drones is well worth it. And so when I think about, subject to the panel, future of autonomy, what she started us off with again, and what Salsa's been hitting here is, in an uncontested environment, we get the luxury of all of these capabilities, connectivity, the ability to constantly monitor health and status of drones, be able to pull FMV feeds all the way back from the edge to, do ML-based analytics, well far away from the edge. But when we say that we need these low-cost systems to be able to function autonomously in field and environments where GPS is gone, when Comlink is gone, and we still need to deliver outcomes, we don't need them to be the absolute best of the best. All we need to do is make them a bit more survivable, a bit more autonomous in field, so that we start to take 10,000 down to maybe only 3,000, down to only 1,000, even though we still put 10,000 in field. So we increase their effectiveness, their ability to survive in these environments, the ability to take human out of the loop for some of these critical decisions, again, to deliver real outcomes in these types of environments. And it's not this, crazy, AI super future Skynet world, right? It's just, can I get a little bit better local positioning with visual inertial odometry? Can I get a little bit better?
Great.
Can I get a little bit better global positioning with maybe not GPS enabled solutions, but maybe preloaded imagery data sets, elevation data sets, and being able to recognize global positioning, local positioning, and do it with alternative means that don't require comm. And that right there is a relatively simple approach with existing technology. This all exists today. There's nothing like, oh man, we got to build all this stuff. It's like, no, it's just the right level of autonomy to get us to take what works today in Ukraine and make it a bit better, a bit more survivable, but still keep the systems really cheap. That's the future when I look at it.
I love it. All right, we've got 1 minute left, so each of you 20 seconds or less. As you think about the future of autonomy, what are you most excited about?
Everything Salsa said.
Yes.
I didn't get on my
homogenous.
I didn't get on my soapbox. I don't love the word autonomy. I would use robotics because when we talk about robotics, we talk about
Didn't
sensing.
you pick the name of the panel?
We talk about sensing, we talk about computer vision, we talk about trajectory planning, we talk about visual inertial odometry, we talk about specific things that robots need to be effective in the future, that all robots need: ground, air, sea, underwater. Now we start moving forward for the future of autonomy.
Yeah, I'll just say everything that we're talking about right now, if we're successful in doing everything that this discussion has been about, it can actually influence a change in the broader ecosystem of platform designers that makes them more open, more easy to deploy third-party software to, and we start to break open a lot of the silos that are really impacting our ability to move quicker, get more kit to field that's more interoperable, where we don't wind up with F-22s that don't talk to F-35s, things like that. That's kind of what I think this opens the pathway to, especially if we get more and more industry performers building their platform specifically to be interoperable with the back end that Chee and Salsa are developing.
Awesome. I'm trying to keep us on time. So thank everybody for spending a little bit of time with us. Guys, thanks for all the brain juice. And thanks to Rise 8 for always putting on an unbelievable event. So thanks, everybody.